Hello everyone. So I hope this is all working all fine. So today I'm going to tell you about an open source project. I hope you see the slides as well. Today I'm going to tell you about Tournesol, which is an open source project that we've started around 2 years ago to do collaborative algorithmic governance of some of what we believe to be the most influential algorithms of today, namely recommendation algorithms, which drive so much of the flow of information worldwide, with a lot of concerns like the spread of disinformation or the spread of hate. So I'm going to focus on the problem to start with, and to really convince you that there's something that a lot of more people should be working on, which is what I've just said. More precisely, whenever anyone makes a query on YouTube, or on Google, or on Twitter, on TikTok, and so on, it's really important to put yourself in the shoes at some point of the algorithm, to realize that quite often it's actually like not more often than not, but quite often it is actually a matter of life and death, the kind of recommendations you're going to give. So whenever someone is searching, for instance, vaccination kills, then it's potentially a matter of life or death, whether you're going to recommend this or that content. And sometimes the kind of recommendation you should be making can be extremely difficult to figure out. It's really an ethical dilemma. Arguably, if you had to talk to you can think of anyone who maybe is inclined to believe in like conspiracy theories, or denies climate change, or like wants to go to war against another country, what would be, you have to think about this, but what would be the best video out of all YouTube to recommend to this person? This is like a very challenging question, and it's really the question that we believe should be addressed a lot more by the computer science community, because after all, we are doing information science, and the information technologies that we are developing are really driving a lot of the information that's propagated online. And unfortunately, sometimes things can go very, very badly, as has been the case in Myanmar. So a few weeks ago, like 5 years ago, the United Nations already recognized that Facebook played a major part in the promotion and the propagation of hate in Myanmar against a community called the Rohingya, which is a Muslim community in Myanmar. And a few weeks ago, Amnesty International also published a report that pointed out that Facebook really exacerbated, vastly amplified the problem, and arguably a driving force of the genocide that has been going on there, and the fact that over 500,000 Rohingyas had to move to another countries, namely to Bangladesh. And this is just one case out of so many other cases. Like in so many different countries around the world, information is absolutely critical, and the way the information is communicated from one person to another can play a vital role. We've seen this in Ukraine, in Russia, but of course currently in Iran as well. And I could mention as well the case of Yemen, or the case of Ethiopia, and even in Western countries with, for instance, the Capitol riots in the US. This kind of issues is also reaching even solid democracy, such as Switzerland, where I'm lucky to be based at. And especially with the COVID, that there have been rise not only of anti-vax movements, but more worryingly of violent anti-vax movements. And so there's a documentary about this. And so maybe something that's not very well known even by Swiss people is that the president of the Commission for Vaccination in Switzerland has been kidnapped at some point by an anti-vax believer. So this really shows the extent to which these issues of hate and disinformation can really be a matter of security for a lot of people, but even of national security. Here, we're really talking about like the leaders of vaccination movements being kidnapped. So that's really a threat for global health, especially if these kind of concerns are increasing. Like the documentary also talks about politicians, for instance, who out of fear for their own security did not give some talks at different places. So really, like, democracy here is arguably at stake. What can be even more concerning is as geopolitical tensions are on the rise. We've seen this, for instance, between China and Taiwan, and in many other countries in the world. There's also more and more concerns that the war is going to take different forms, and the more people are like in the spirit of hating others, the more likely it is that some serious catastrophic event can happen. So typically, one major concern could be cybersecurity. So you might have heard of Log4j. I guess most of you have heard of Log4j. And so this, which is a critical vulnerability that in a product that was used by a lot of people, a lot of companies. And this vulnerability was actually found by Alibaba, by researchers at Alibaba, and and they reported it directly to Oracle. But the Chinese regulators did not see it with a good eye, and they actually punished Alibaba for having communicated the vulnerability to Oracle instead of communicating it to the Chinese regulators. You can really imagine, like, the danger that this represents if only China and only the Chinese government is aware of this critical arbitrary code execution vulnerability. Then like, this government has a strong leverage to put a lot of major information systems in huge danger. Like they can stop them, or even make them cause harms to the users, and so on. So this is extremely concerning. And of course, the war can take more violent forms still, typically nuclear war, or just drones that are more and more common these days. So I hope I've convinced you that there's an issue currently with the way information is dealt with, especially on the internet. And I want to stress again that a lot of the way information is spread on the internet has to do with algorithms. Algorithms really play nowadays a critical role in what kind of information is amplified. And there's a lot of attacks on these algorithms, for instance, called astroturfing, trying to promote certain views rather than others. And there's really an information war that's going on. And I hope I've convinced you that this is a big deal. Now, I don't want to stress too much the problem. I hope I've convinced you of this already. I want to talk more about what we can do about this. And the first thing we can really observe is that currently there's very little solutions to this problem. Like, currently the algorithms are designed in a very opaque manner, and there's very little research into how to design algorithms, recommendation algorithms in particular, that are not going to hugely favor harassing and cyberbullying and all sorts of disinformation and hate, and how to instead use these algorithms to actually promote some beneficial views, some empathy or sympathy, at least, or compassion for others, some quality information, especially on topics like climate change or public health. I think it's really important to come up with solutions that are practical and that could replace, for instance, the YouTube algorithm in the long run, or maybe that can be added partly or somehow to the YouTube algorithm to improve it in the short run. And that's really our goal here with the project Tournesol that we've launched over 2 years ago. And the idea of Tournesol is to have a collaborative approach. Instead of having one single entity unilaterally and often opaquely deciding what kind of content will be promoted at scale, and what kind of algorithms will be doing this. In Tournesol, what we propose to do is to have a recommendation algorithm that's collaboratively designed. In other words, there will be a lot of contributors that come to Tournesol. Actually, anyone can come to Tournesol and create an account. And anyone who does so will be contributing to essentially building up the recommendation algorithm. And this recommendation algorithm will then make recommendations that are representative of the preferences, of the judgments made by our contributors. Now, a judgment in particular on Tournesol, like we don't ask people to score videos independently, because there's a lot of issues with this, with the reliability of these scores and the quality of these judgments. In particular, if you have scales from 0 to 5, then you can see quite often on Amazon, for instance, or on websites like this, that people use like the maximum scores very quickly. And this means that it's very hard then to distinguish between top quality videos, and yet there's a lot of differences between top quality videos. Like there are some videos that are that may be much more urgent to spread than others, even though the others are of high quality as well. So instead, what we ask our contributors to do is to compare, to put themselves in the shoes of YouTube. So if you are YouTube, then you can only make one recommendation at a time. You cannot recommend all of the great videos at once. But you have to and you have to decide every time, out of all of the videos on YouTube, which one you would be recommending more often than the others. And so what we propose, what we ask the contributors to do is to select any videos on YouTube. So you can just copy paste the URL in the interface, and then you can tell the Tournesol algorithm, well, out of these two videos, for instance, I believe that the video on the right here, the slider is slightly on the right, should be more largely recommended. But here, like the slider is only slightly on the right, so it's only slightly more recommended, meaning that the order on the left should also be recommended often according to the user. And then by doing so, like the contributors, especially if they do this contribution publicly, so there are like buttons here to select whether you score videos publicly or privately. If they do this publicly, then the judgment itself is recorded in a public database. And this public database is public under a very open license, and anyone can use it to then train their own algorithms or to look at it and find interesting patterns in the data. More importantly, Tournesol uses these data to actually make recommendations. And so if you're using the browser extensions, we have a browser extension for Chrome and Firefox web browsers. Then if you use our extension, then whenever you go on YouTube, you will have this panel here with the recommendations made by Tournesol, so indirectly made by the community of Tournesol contributors. And the hope is that as more and more people are exposed to greater quality information, then we can steer away from disinformation and hate, and have a more constructive approach to building the future of our societies. Now, I stress again that the database is public. I forgot to translate this in English, but the website is both in French and in English, so you can select it. And so, well, the license is Open Data Commons Attribution License, ODCBY, which is like very, very open, like reusable for commercial purposes and so on. Now, if you want to contribute to Tournesol, of course, you can provide these judgments, these comparisons, and help identify top quality content on YouTube. But another thing you can do is, as programmers, is to contribute to our code base. And so we have our project is open source on the AGPL license, the code. And you can go on our GitHub. So it's github.com slash Tournesol-app/Tournesol. And if you filter by good first issues, you can find good first issues. But we ask that you contact us just to let us know that you want to work on this or that, and maybe to get a few advice on how to best go with the issue. So there's a document contributing that MD that contains like instructions to get started if you want to contribute to the code base of Tournesol. Now, so Tournesol is like the way I've presented Tournesol so far. Like it may seem like a nice presentation, like a nice project. But if it was not secure, it would be extremely dangerous. Like, it would be extremely easy to hack Tournesol, to have a few malicious contributors creating fake accounts on Tournesol, and to then bias Tournesol so that it recommends, for instance, very hateful videos. This is a major concern, and it's actually much of my background. Like, I'm really over the last 5 years, I've really worked on secure algorithms, especially secure machine learning. And I want to stress that this is an issue for all participatory algorithms. As long as you rely on user-generated data, that is data provided by some users that you don't personally know, then there's a risk that these users are actually trolls from an authoritarian country that are trying to pollute the database to harm your system, or even worse, to bias it so that they promote some views. Maybe, for instance, the views that democracies are not sufficient to handle the big crises of the future. And so it's very critical to secure the system against these kinds of attacks. Now, unfortunately, like today's large-scale algorithms, if you think about the YouTube recommendation algorithm or the Facebook newsfeed algorithm, these algorithms are usually not that secure. And to really stress how big of an issue it is, I just want you to reflect, to guess how many fake accounts Facebook is removing from its platform every year. What do you think is the number of fake accounts that Facebook removes from its platform every year? What is the order of magnitude? Are we talking about thousands of fake accounts, or tens of thousands, hundreds of thousands? I can tell you the answer. The answer is around 7 billion fake accounts. So every year, Facebook removes as many fake accounts as there are humans in the world. Every year, like 7 billion fake accounts. So it's increasing. So I think now it's more like 8 billion, but that's the order of magnitude. And so you have to realize that this is Facebook. Like, Facebook has a lot of means. Facebook is under huge pressure from advertisers to make sure that the users are humans and are authentic. So Facebook is actually investing quite a lot in trying to combat these fake accounts. But you can really imagine that on other platforms like Twitter or Reddit that do not try to have this idea of one account, one user, then in all of these platforms, like, most accounts are fake. Like the overwhelming majority of accounts are probably fake on these platforms. And these fake accounts are really are really providing a lot of data. And what's really concerning is that today's machine learning algorithms are really learning from all kinds of data. And maybe like the recommendation algorithm, which is a learning algorithm, but also like the moderation algorithm, the captioning algorithm for YouTube. Like there's a lot of algorithms out there, like the algorithms that learn humans' behaviors and try to anticipate what they're going to click on. All of these algorithms may be mostly trained on factitious data, on fabricated data that are fabricated potentially by malicious actors. And this means that the algorithms are learning from very bad data, and thus they can be themselves very, very hacked. So it's really important to secure the training and these kinds of systems. So I want to talk now about this secure voting algorithm that we've designed for Tournesol. I'm not going to go into all of the details at all, because it's more complicated than what I'm going to present, but I'm going to give you hopefully the key ideas, the key intuitions for why we achieve some kind of robustness, of a guaranteed robustness on Tournesol. Yeah, so I want to stress in particular that the problem of robustness is very challenging. So what we do on Tournesol is we assign a score to every video, and the score should be representing the collaborative judgment of the community. And what's really tricky is that if these scores were not well protected, and even if you use like some statistically robust functions like the median, like the median is often considered like more robust than the mean, then would still be not sufficient, because an easy attack is that if I'm a malicious user and I'm on Tournesol, I could just take the worst kind of video on YouTube that nobody has ever rated on Tournesol. I can bring it on Tournesol and I can score it myself. And since I would be the only one scoring this video, if there was no like protection, then the score of the video could be what I decide. If you take, for instance, the median of all of the scores that have of all of the people who have scored this video, then given that I'm the only one who scored this video, the median is equal to my score. So I would be in control of the score of videos that nobody else scored. So we really need to protect against this, and this required the new algorithms to do so. And the basic idea is still related to the median. It uses a concept from that's related to an older tale of the swan, the spike, the pike, and the crawfish. So it's a Russian tale where like everyone is like pulling in one direction, some car, and like nothing would be moving because everyone is pulling in different directions. So like the tale was introduced to argue that if everyone is doing things in their own ways, then like the society does not make progress. And that's kind of like the original reason why this tale was introduced. But you can have another interpretation of this, like assuming that everyone is actually pulling towards their preferred direction, towards where they think the car should be going. Then if everyone was doing this, then the position that is currently the position of the car would be okay, would be a compromise in a sense, because like everyone is pulling and everyone, like there's kind of an agreement that this is like okay for everyone, like because everyone is pulling towards their preferred direction, as opposed to if like the car was like very far away and everyone wanted to go in the same direction, then there would be a consensus to pull the car towards another direction, and so the position of the car would not be satisfactory before people pull. So anyways, what I'm describing here is what we decided to apply to Tournesol. So let's say I have like 5 contributors to this video, and they all have different preferred scores. Like they all claim that this video should have a given score. Now the question is, what should be the Tournesol score? What should be the aggregation of all of these judgments? Well, our idea is to reuse this idea by considering that everyone is like acting kind of like a crawfish. So they're putting a crawfish at their preferred score, and all of the crawfishes are now going to pull with a rope on the Tournesol score. So you can imagine here in this situation here that you would have one person here pulling towards the left, pulling the global score towards the left, whereas the 4 others would be pulling towards the right. So if I draw the pulls on the global score, you can see you have 4 forces towards the right and 1 force towards the left. So if I add up all of the forces, then this gives me 3 forces towards the right. So in this setting, like the video would be moved towards the right by the right crawfishes. Now, if we move to this situation, now if the score is here, then the crawfishes are still pulling towards them. So crawfishes are always pulling towards them. But in this setting, you can see that 3 crawfishes would be pulling towards the left and 2 crawfishes would be pulling towards the right. And as a result, the video would be moving towards the left. Now, you can try to think a little bit about what would be an equilibrium point. What happens when everyone keeps pulling and in the end, the score of the video does not move? What is this point? Well, the answer, well, it would be here. It would be here because in this setting, like you have 2 crawfishes, this one and this one, that pull towards the left, and 2 crawfishes that pull towards the right, and this one is just pulling towards the center, towards itself. So like the sum of forces like cancel out, and this is thus an equilibrium point. Now, this equilibrium point, you may have noticed that this is actually the median of all of the scores, right? The median is separating everyone's such that the number of people on the left is the same as the number of people on the right, and thus this really corresponds to when everyone pools, the sum of forces cancel out. But as we've said, like the median is not satisfactory because if there's only one person, then this person, and if we use the median, then this person can pull the global score towards their preferred score. And if this person is malicious, then it's very bad. Now, the trick we introduce is to just consider that everything is happening in a parabolic valley. So in other terms, mathematical terms, this corresponds to saying that there's a quadratic regularization. And so what happens now with the quadratic valley? Well, in the quadratic valley, the equilibrium would be more slightly towards the left. Why? Because here you would have 3 crayfishes pulling towards the right, 2 crayfishes towards the left, but you would also have gravity. And because the slope is this way, the gravity is going to be pulling towards the left. So you would have gravity plus 2 crayfishes against 3 crayfishes, and this could cancel out. Now, what's really nice with this quadratic regularization is that if there's here, let's say you have 2 contributors that are trying to completely bias the scores of this video into very, very high scores, let's say because they are malicious or like, this may happen, then what happens is that their combined pool is at most of 2 unit forces. But because of gravity and because the slope is increasing as we move more and more towards the right, there's only these 2 contributors will only be able to pull the global scores up to a certain point, to a point where like gravity, like the slope becomes too big, and like the like gravity plus like the normal force, if you want to be a physicist, gives a force towards the left that is too that is compensating the 2 pools of the 2 contributors. In fact, you can prove mathematically that what happens is that, assuming that you have voters with a certain voting right, and the voting right corresponds to the force with which they pool, then you can show that how much they can pool a score is directly proportional to the voting right that they have. The more you have voting rights you have, or combined voting rights if you are multiple people, the more you can pool. But if you don't have enough voting rights, because of gravity, you cannot pool that much. You cannot completely bias the global scores. Okay. So before the conclusion, I want to stress again the issue with security. And I want to talk in particular about something called ML security operations. I think it's really important that we think a lot like that the machine learning community, and that everyone who is working with anyone else who's working machine learning is more aware of the issues around machine learning, and in particular its deployment, so machine learning operations, and in particular, and more specifically still, about the security of this deployment of machine learning algorithms. To realize the importance of this, it's important to stress that so far machine learning has mostly been academic. Like it's already deployed at scale in many different settings, but most of the study of machine learning has been very academic in a non-deployed system. And it's very different between machine learning in the lab, where you control everything, you have to pull your data, you don't interact with users, and the machine learning systems that's deployed, especially on the internet, where it's going to be interacting with a lot of unknown users, sometimes thousands, millions, and in the case of Facebook or Google, with billions of users. Now, this transition from the lab to the wide, to the web, is very challenging. It raises a lot of security issues. And it has, the kind of issues you're going to face when deploying these kind of algorithms is essentially studied in academia as adversarial machine learning. So adversarial machine learning is assuming that when you deploy the machine learning or when you build the machine learning algorithms, you're going to have people who are participating in the system, whether it's because they're providing data or computational resources, or maybe they are actually the ones doing the computations and you don't trust them. Then the one who is doing the computation would be an adversary. And so adversarial machine learning is a field that's rising. It now has its Wikipedia page, but arguably it's still way too much underdeveloped, even in academia, but even more so in the industry. So there's been a survey by researchers at IBM, I think, that interviewed different like companies and especially groups doing data science. And that showed that practitioners report a dire need for better protecting machine learning systems in industrial applications. I think it's really urgent, and especially in the current geopolitical context. To really stress how much of a problem it is, I think in cybersecurity in general, one thing that's extremely scary is if an attacker is able to modify the code you are shipping. So imagine you develop a code, and one of the big concerns is whether an attacker can change this code and before it gets shipped. Now you have to imagine that in machine learning, this is what's happening. Like literally, those who send you data are going to modify your algorithms before you ship the algorithm. So this is a huge risk, especially like if you're using user-generated data. And there are also all sorts of other attacks. I'm not going to dwell too much on them, like evasion attacks. So what I'm describing is like data poisoning attacks, like Byzantine attacks, or other kind of attacks that have more to do with computational resources owned by other people. And if you ask them to do a computation, then it's not clear they are actually going to do it. And model extraction has to do with privacy concerns and just model stealing as well. In case of company spying. There are also other concerns that are sometimes extremely practical. So for instance, there's a new recent paper by different researchers, including Shafi Goldwasser, who's a Turing Prize award winner. And in this paper, they actually showed that it's very easy to plant undetectable, provably undetectable backdoors in machine learning algorithms. So this means that if you trust another system to do the computation for you, so typically if you're using Amazon Web Services or Google Cloud to do the computations for you, then given this paper shows that it's very easy for Amazon or for Google to plant an undetectable backdoors. So undetectable means provably undetectable. It means that if you to determine whether there is a backdoor or not, you would need exponentially, it's like NP hard, more precisely. It's NP hard to determine whether. So you would need typically to do exponentially many queries, if P is different from NP, to the machine learning algorithm to determine if there is a backdoor. So essentially, it's impossible. And so if you have these undetectable backdoors, then like the attacker knows what kind of how data can be modified to be labeled very differently. So typically, if it's a moderation algorithm, then the attacker who planted a backdoor can modify any thing it does, or any post it writes, for instance, so that it does not get detected as something harmful to be removed from the platform. And so if you think about like fraud detection and stuff like this can be more concerning still. So yeah, that's the issue of trusting other computational other people other people to do the computation for you. And there's an obvious case where this is the case. It's like most algorithms by Google are constructed by Google themselves, so Google can easily plant undetectable backdoors in their machine learning systems. Of course, the same hold for any company. Another kind of attack that has been on the rise, that has been exposed recently, is due to very bad habits in the machine learning community. So in the machine learning community, it's very common to share models and to download others' models, and then to start with other people's models, and then to fine tune them for your purposes. And this is actually very dangerous, not only because the model may have undetectable backdoors, but also actually because there's an arbitrary code execution vulnerability in the algorithms that do this extraction. It uses, especially if you use, especially PyTorch that uses pickle, which has arbitrary behavior. So yeah, that's also a huge risk, and you can think of many kinds of attacks that can be done on many companies that could steal data or paralyze system through this kind of attacks. So yeah, I think it's high time that we consider the security of these systems with much more investments and seriousness and attention. And I'm very happy to see, for instance, that the European Union is going more and more in this way with the Cyber Resilience Act and the AI Act and the Digital Services Act, among others. But I think we need more also companies should be concerned about this, especially we're entering an age of cyber warfare. And so I just want to mention that with colleagues who are also experts in security of machine learning, we are starting Calicarpa, a company that is trying to accompany companies into understanding the risks related to machine learning systems. Yeah, so with this, I'm moving on to the conclusion. So the main conclusion I want to stress is that, again, we have huge issues with information systems that have already been exposed multiple times by many different entities, like lately by the Facebook files, for instance, and that really show that many societies, including solid democracies, are in danger because of the spread of disinformation, hate, tensions, and risks even of potential wars that come out of this. I think it's very important that we pay a lot more attention, a lot more investments in securing our information systems, and in particular in promoting higher quality information on social medias. In particular, the open source project Tournesol, which is led by a non-profit association, the Tournesol Association, is really desperate really needs a lot more help. Right now, it's been 2 years and a half, but it's still we still have only one employee. It's mostly volunteers trying to make progress on this project. And so we really need all kinds of helps to make Tournesol more resilient and more solid, more user-friendly, but also, and more importantly, more compelling. We really need Tournesol to be something that researchers talk about, that regulators can be using, for instance, to audit other kinds of algorithms by tracking what kind of quality of information they are spreading on a regular basis. And of course, for this, we need the open source community to help us make progress on this. So if you want to know more, there's all sorts of different resources that I could point out. So there's a book that written with Mehdi Hamdi, who's a researcher in AI ethics at Google and professor at École Polytechnique, who's been really in the whole very weird situation of Google firing Tim Gobu and Margaret Mitchell a few years ago. But unfortunately, this book is only in French. I also wrote another science fiction book to raise awareness about risks of uncontrolled machine learning systems called Smart Poop. It's in French and in English, available on GitHub. It's also on purchase on Amazon for the physical version of the book. And there's also the white paper of Tournesol that describes the project in more details than what I've done here. And I'm also doing YouTube videos. So if you're interested in this, you can also search a bit. The channel is called Science for All. And with this, thank you for your attention, and I'm willing to take questions.
Well, Lei, thank you so much for starting our day today with a talk that is fascinating and timely and really addresses something that we all deal with every day in our digital world. So thank you so much for that. We're going to jump into questions. I think we have a question already, and maybe as time goes on, the algorithm will catch up and we'll get more questions.
I guess the question is it correct to say that the Tournesol approach is meant to serve recommendations that the community of a given site wants to see on average, as in it underlines, reinforces the general community's existing learning? Yeah, definitely. And this raises all sorts of issues with like the biases of the Tournesol community. So, well, it's a permissionless system in a sense, like anyone can join the Tournesol community. I haven't talked much about this, but there's also like a way to protect against fake accounts. So we use like email certifications, and we also have a vouching systems to protect the system for security reasons. But yeah, it's true that there are going to be biases from the community. But what we believe is that the data itself will be interesting, and if you can, and we're going to try to do this to separate the users into different communities. For instance, you can maybe identify the opinions of those who have a PhD in biology when it comes to vaccinations, or I don't know, something like this. Or so if you can identify sub communities, then you can also understand what are the recommendations of these kind of sub-communities. And we would be very interested, for instance, in working with organizations like the World Health Organization or the IPCC, and to have them using Tournesol to know what they see as quality content that should be recommended.
Fantastic. All right, I think that is all the questions we have. Oh, there's another one. Okay, so I'm assuming you're using Scala for this project. Could you show some more details about your code base?
Yeah, so actually we don't use Scala in this project. Sorry about that. So what we use is, so we have Django in the backend, so in Python. That's interfacing a little bit with machine learning. That's done actually more with SciPy and NumPy. And we are in the front end, it's React, so JavaScript.
Okay. All right. And we'll wait just another second here. And I don't think we have any more questions. So Lei, thank you so much for being here with us at ScalaCon. Thank you for your talk, and hope you enjoy the rest of the conference.
Yeah, thank you for the invitation. Bye.
Fire in retro rock.
Roger, Matt. Ready to eject.